everybody, this is Mrs. Snook with section 8.2, multiplying and factoring. And we're going to do two things today. We're going to multiply a monomial by a polynomial, and that might look something like this. 4 times x squared plus 2x plus 1. So we would actually multiply those two quantities together. And the other thing we're going to do is go the other way. We're going to factor a monomial from a polynomial. So that would look something like this if I had 4x squared plus 8x plus 4. I will actually be able to factor that out, and my answer would be this. And I think of it as going forwards and going backwards. Forwards would be when I'm multiplying the monomial by the polynomial, and then backwards would be factoring it, which would bring me right back to having my original monomial, which is that 4. And the x squared plus 2x plus 1, that's our polynomial. So let's get started. Here's our first problem. You set aside part of a rectangular plot of land for a garden and seed the rest of the plot with grass as shown. Grass seed costs $0.03 per square foot, or 3 cents. We're going to write an expression for the total cost of the seed, and then suppose you buy $50 worth of seed, how wide can your section of grass be? So first part is getting ourselves an expression for the total cost of the seed. So I'm going to say C is our total cost. Now I know that the area of a rectangle is length times width, and the length of my grassy area is X, but you see this little 10-foot section on the side? I got to take that 10 feet out because that's not going to be grass. And then the width is the 45 feet. And I know that we said 3 cents per square foot, so I need to multiply this whole thing by 0.03. And then when I get my expression, I'm actually going to multiply the 45 by the 0.03. And I get 1.35 times x minus 10. And then if I wanted to find out the cost of the grass seed, I could actually multiply each of these terms together. And we'll be doing that a little bit later. Now the second part is, suppose you buy $50 worth of seed. So my C is going to equal $50. How wide can my section of grass be? So in my expression that I wrote, I'm going to put in 50. So 50 equals 1.35 times x minus 10. Let's go ahead and divide both sides by 1.35. I'll end up with x minus 10 over here, and 50 divided by 1.35, I get 37.04. Now this is a nice easy equation that you've been solving since the start of the year. Just add 10 to both sides, and x is going to equal 47.04. So that says that this stretch of land here would be 47.04 feet. Okay, so let's start multiplying monomials with a trinomial. Now, tri means 3, so trinomials have 3 terms. So if you look at example A, we have negative x to the third, that's your monomial. And we have 9x to the fourth minus 2x cubed plus 7. That's our polynomial. And when I multiply those out, what I'm literally going to do is I'm going to take this negative x cubed and I'm going to multiply it first by the 9x to the fourth. So a negative 1 times 9 is a negative 9. And then remember your rules of exponents from chapter 7. X to the 3 times x to the 4 is x to the 7. Now I'm going to do the same thing with my second term, my negative 2x cubed. I'm going to multiply negative x cubed times negative 2x cubed. Well, negative 1 times negative 2 is a plus 2. And then x cubed times x cubed is x to the 6th. Now there's one more term here. There's that plus 7. So I'm going to multiply that one. Negative x cubed times plus 7. I have a negative times a positive 7 gives me a negative 7. And then I just have an x cubed, and there's no other variable there. So this is just x cubed. Now let's do the same thing with example B. First term, 5 times 3 is 15, and then n times n to the 3 is n to the 4th. Second term, negative 5, n times n squared is n cubed. And then 5n times an 8, 5 times 8 is 40, and then n. And that's pretty much all you have to do for these. So in terms of showing work, there's not much to show. All right, now we're going to start going backwards. And this is where we find a common factor that we can pull out of each of our terms. What we're looking for is the greatest common factor. And that's going to be the largest factor that we can pull out of all three of our terms. Now there's two things to check for when you're looking for a greatest common factor. First of all is check your numbers. And then second, check the variables. When I was in school, I would always forget the numbers. I would see the variables but not the numbers. So I always had to remind myself to check both of them. So let's look at A. We have 5x cubed plus 25x squared plus 45x. I'm going to look at the numbers first. The 5, the 25, and the 45. And I'm going to see if there's a number that I can pull out of all three of those. And that number is 5. So I'm going to put my 5 over here. I'm going to put a parentheses. Now the next thing I need to check is the variables. Is there a variable I can pull out? So I'm checking x cubed, x squared, and x. Now all three of them have an x term, and now I need to figure out how big of an x term I can pull out. Well, I've got x cubed and x squared and x. And the one that I can pull out is the x. It's actually the smallest one. And the reason for that is I can pull an x out of 45x, but I can't pull an x squared out of 45x. So you actually end up looking for the smallest one that is in all three of them, and that's the x. So my GCF is just 5x. Now take a look at B. We have 3x to the 4th minus 9x squared minus 12x. Checking my numbers, 3, 9, and 12. I can pull a 3 out. Now check your variables, x to the 4th, x squared, and x. I can pull an x out. And that's done. Okay, now once we are capable of pulling out that greatest common factor, that's actually the monomial that we're going to pull out. We're going to factor out our greatest common factor. So the first thing I'm going to do is identify that greatest common factor. So when I look at A, I have a 4, a negative 24, and an 8. I can pull 4 out of all of those. So I'm going to have 4 as part of my GCF. And then look at your variables, x to the 5th, x cubed, and x. I can pull an x out. So I now have my GCF. which is 4x. So step 1 is GCF. Step 2, believe it or not, is just factor. And I'm going to do each term, just one at a time. So I'm going to put in a parentheses because my answer is going to go inside those parentheses. And I'm going to write down on the side what I'm doing in my head. And then I'm just going to write down the answer as I go. So the first thing I'm doing is we have 4x to the 5th. And in my head, I'm dividing that by the common factor 4x. And what I'm going to say out loud is 4x to the 5th, pull out 4x. So that's what I'm saying out loud. I'm going to write down what I get when I do that division. So my 4's cancel, and I have 1x, and it's going to cancel with x to the 5th and give me x to the 4th, so then I just write down x to the 4th. Next term, negative 24x cubed, pull out 4x. In my head, I'm doing this. My 24 and 4 cancels. I'm left with a negative 6. And then x cancels with x cubed. That leaves me an x squared. So I write that down. So I have a negative 6x squared. Last term, 8x, pull out 4x. In my head, I'm thinking 8x over 4x. 8 over 4 is 2. My x's cancel, so I have a plus 2. So that's my factored form. I have a monomial over here, and I have a polynomial in here. All right, let's do another one. Looking at 9, 15, and 12, I can pull out a 3. Looking at x to the 6th, x to the 4th, and x squared, I can pull out an x squared, put in my parentheses. Now 9x to the 6th, pull out 3x squared, I get a 3x to the 4th. Next term, 15x to the 4th, pull out 3x squared, I get a 5x squared. Last term, 12x squared, pull out 3x squared, I get a 4. And that one's done. Okay, so now let's model a real-life situation with factoring a polynomial. We have a helipad, which is a place where a helicopter lands. It's a landing pad. And it's sometimes marked with a circle inside a square, so it's visible from the air. And oftentimes you'll see these at hospitals, typically on the roof of the hospital, and the helicopter might be bringing in a critical patient, and they would land on the roof inside that circle and square. So we're going to find the area of the shaded region of the helipad, and that's going to be this area in red. And the shaded area of the region is going to be the square that we factored. So area of shaded is going to be the area of that square, so the square on the outside, minus the area of the circle. Because when I subtract the circle from the square, what's left is those red shaded areas. So let's see, what's the area of a square? Well, the area of a square is the side squared. Now in our picture, the side is marked as 2x. So I'm going to take 2x and I'm going to square that. And as you know from last chapter, that's 4x squared. Now let's get the area of the circle. Area of the circle is pi r squared, where r is the radius. Looking at our picture, the radius is x. So I'm going to get pi x squared as the area of my circle. Now all I've got to do is a subtraction. So the area of the shaded is going to be the area of my square, which is 4x squared, minus the area of the circle, which is pi x squared. it says to write our answer in factored form. So I'm going to have to factor this. And I'm going to check for a GCF, a greatest common factor. I'm looking at the numbers 4 and pi. No help there. So now look at your variables, and you have an x squared in both terms. So I can pull an x squared out of both terms. 4x squared, pull out an x squared, I have a 4. Negative pi x squared, pull out an x squared there, I have a negative pi. So here's my answer in factored form. X squared times 4 minus pi. That's it for today, everyone. Thank you for watching and have a great day.